Well, thank you. Before I start, thank you for the organizers to accept my last-minute invitation. This week I was attending, as you can see, the Progressive Web App Dev Summit that was happening here in Amsterdam. And usually when I go to some event, I try to do a talk, maybe present a workshop, or do something for the community. And in this case, well, you are, the meetup group that has accepted it. So today I'm planning to talk about RxJS. And basically I'm an Angular guy. So this is relevant to the Angular community because Angular 2 is built around RxJS version 5. And I'd like to know how many of you have already experienced with RxJS. Okay, more or less, a little bit. Okay, so maybe this is maybe too in-depth talk. I'll try to keep it really simple. So RxJS is basically this is the first reaction from the people. So RxJS is the library that implements observables, or you can also use streams. So either for streams or observables, you can use RxJS. We are going to talk about RxJS 5. That is basically a rewrite from RxJS 4. And this was focused on performance, and it started when the Angular 2 team was looking into some nice implementation for live data, and obviously to work with streams. And it's really important for the Angular team to base all these communications in a solid library, and that's basically the role of RxJS. Basically, what you can think, some people, the easiest definition is Lodash for events. So that's basically like a library that helps you to handle events in a powerful and easy way. And today I'm going to run this talk. This is a unconventional format. And basically what I'm going to do is run some of these tasks. And I didn't connect. We need to set up the internet. Sorry for that. I got a little bit excited. What I'm going to do is while I'm getting the network, what I'm going to do is start showing what will be the stream that I'm going to code. So we're going to use the ASCII marble notation, and this is the timeline. And basically a stream will allow us to push values into it. So this is the timeline. There will be some time, some delay. We will get one value, number 1. Then we get another value, and this is more or less how it will work. We will stop it after the third value. And what I'm going to start is defining the different interfaces. So I'm going to start with observer. And this is basically defining some methods. And I'm going to start with the next method. Okay. Let me just do this quick. Okay, that's the errors that we're getting on the right. Well, that's what happens. Okay, let's remove this. So, okay, we are implementing the next. This is in order to push values into the stream. Then we also have the complete method. We are going to define these event handlers, and I'm going to use the pipe just to follow the notation that we defined at the beginning. Then I'm going to use the interface from Rx library that's observable. And I'm going to use first a helper. This is a utility method that will just get these values and just push them into the stream. And then when it gets into the last one, it will just trigger complete. And we set, with the observer, we set the behavior. So this is more or less how we define, we work with observables. We first set up the observable, how we want to process it, and then we will use subscribe to execute it. So subscribe will return a subscription. And we are going to pass the observer that we define it just at the beginning. So if I run this code now, we should get the sequence that we defined at the beginning. So that's basically the most basic operator that exists. So we can pass values, we can pass objects, arrays. In this case, I'm just passing a list of arguments. Obviously, that's not really what we want to do. So I'm going to just implement the same observable using the Create API. So you can see what's going on inside, how we are going to implement the same utility method, but on ourselves. So I'm going to use the observer function, and this is exactly the object that we defined just before. And I'm going to just push these values. So you will see that it's really easy. And I'm just going to implement the same behavior that we have seen before. So it's just the 3 values, and then I'm going to call complete. So this will be the first observable that I'm going to create. And just for a quick, just to check the output, we are getting the same result that we were getting before. But now you can see, the internals of the observable. So that's the way I'm going to approach this talk. So that's the first step out of the way. Now the second cone, it will be adding error handling. So let's see what I'm going to go for. So let's suppose we push the first value into the stream, and then we get some error. How are we going to implement this? So the way we implement this in using RxJS is implementing a new method that will be the error method, and we are going to use just output this error. Like, obviously you can add your logic. It's not just outputting the values out on the console. You can add more complex logic, obviously. And we are going to just throw an error here, and I'm going to use the same X, the capital X that we use on the marble diagrams. So let's see what happens now. What we get now is an uncut exception that will stop our program, and usually that's not what we want. So the easy way to fix this is just wrapping this into a try catch. So I'm going to do just that. Okay, this is obviously this is the calendar for this event. Everything will happen today. Catch. So this is just a regular, exception handling. And what I'm going to use now is this method that I just implemented on the observer. So I'm going to use the observer and call this error and just pass this through. So now what we are going to get is just, we are going to push the error within the same stream, so the subscribers can get this error and then add the proper handling, that is this function here. Obviously this can be different from different observers or different subscriptions. But this is just a very simple example. So this will be the error handling. Obviously, you don't want to be using this because it's adding some more complexity. So I'm going to remove this code just to get the previous version. Okay, we don't need this. And we have actually done the two first koans. The next step is implementing the interval operator. So interval operator will work like this. We will pass some delay. We're going to use half a second. It's using milliseconds as an argument. And we are going to change this interval just to match. So instead of using the utility operator, I'm going to try to implement it myself so you can see it. So the first thing that I'm going to use is I'm going to create like a counter, internal counter. I'm going to use I. So I'm going to start with 1, and then I'm going to use set interval. That basically what will allow me is just to call this anonymous function every amount of seconds. So I'm going to just use the observer, and as we did before, I'm going to use the next, that is just pushing this value within the stream. I'm going to increment this value and use the same delay that I just said that I wanted to use. This will set the interval. So let's just try it. So we get every half a second we get a new value. It's pushed into the stream. We just define what we are going to do with that value in the observer, and that's pretty much it. So we are good so far. What I'm going to add now is a property that promises are missing, and this is one of the difference that sets apart observables from promises, and it's the ability to cancel. So we have this stream that is just emitting new values every half a second, but imagine we have a Twitter feed and we are getting all these tweets like really, really fast. And we are moving to another section of the application and we just don't want more tweets. We don't want to handle this. We don't want to process all these new tweets that are coming. So what we are going to do is use another feature that the observables specifications give us, that it's having the ability to cancel the stream. And we are going to use the API for set interval. We are going to just save a reference to the interval that we have created. And then the way it works is we can return a function, and this will be used when we call unsubscribe. So I'm just going to use clear interval. This is just the API for setting interval, and I'm going to use this token that we just received when we executed this create. So now we can unsubscribe. I'm going to use set timeout, because obviously if I run this code and I just use subscription unsubscribe, it will just be so fast that it will not allow any value. So I'm going to use some delay, and I'm going to use the subscription. You can call it like this, and then we just need some delay. I'm going to pick just a second and a half. Let me just stop it. Okay. Let's do it like this. So basically now, it's when I call subscribe, it's executing this code here. Then it's waiting 1 second and a half, and it's calling unsubscribe. We don't see the complete because we just don't care about what's going on with this stream anymore. If we do a little, we can change this code a little bit. So I'm going to create 2 different subscriptions, and I'm going to show you how you can use this to separate instances, to use the same stream to just do different a different behavior. So I'm going to use unsubscribe only on the first subscription, and for the second one, I'm going to use the same observer that is just, outputting these values. So this will give us, for the first 3 values, it will just, duplicate this output, and then for the following time, it will just be the second subscription that is still alive. And obviously, if I call the second subscription unsubscribe, will stop that one. So that's, I think that's all that covers how to cancel streams. So I'm going to go a little bit back. We are going to continue with the starting observable. That's yeah, that's good. So let me just do some refactoring. So what we want now is start with this observable, and I think the rest is working. Just don't care about the output on the right. So we are going to implement now the map operator, and basically what it's doing is allowing us to define a function, and I'm going to use just a very simple one that will duplicate the value, and that will create another stream, and this one will just have the same values but duplicated. So this is really similar to the map that we use with arrays, and we're just implementing the same on streams. So we start, just to make it exactly the same. So this is going to just push these 3 values, just call complete, and we are going to start with this stream. So just let's clear it out. Yeah, that's a good start. So I'm going to start with defining a function that will be a transform, and this function will be taking input observable. It also will take a function, and it will return a new instance, another observable that I'm going to call output. This, as you can see here, is going to create this observable. I'm using a $, at the end. This is a kind of convention that we use to say that we are working with a stream. And the way I'm going to use transform is just getting the original stream that we created before, and just passing this new function that will duplicate the values. So basically, we are calling the transform function, we are passing the first stream, and then we are passing also the function that we want to apply to each of the values. Obviously, this won't work. I need to create an observable that will just map the values that are coming from the source observable, and then apply the function and give it back as a result. So let's just use the same API that we used before, that is taking an observer, and what we are going to use here is the source observable. That's the input observable, and we are going to subscribe just to do the mapping. In this case, I'm going to just implement the observer right here. I'm not going to create it as I did here. I'm just going to use it as an argument, but it's basically the same. So I'm going to take this function and just using the observer, I'm going to push the value that it's coming and applying the function. So that will be the next. What I have to do also is, when the source observable finish, I also want to finish this output observable. So I'm going to call complete, and it's not taking any arguments, but I'm just going to call the complete on the result. Okay, so that will create a new instance that will be returned, and that will be held by this $B. Now I'm not going to use the $A, I'm going to use the result. And so good so far. This should work. Okay, it works as expected. What I'm going to do is add a little bit of, I'm going to patch the observable type, and this is something that I wouldn't recommend. I'm going to use the prototype to do that. So basically, what I'm going to achieve is a closer usage when I'm calling this transform. So I want this syntax instead of passing the input observable as an argument, and I need to do some refactoring. So now I need to just use this, and this will be the input stream. So let's run this code, see that it's working as expected, and this will be the way that the library is implementing the map function, the map operator. So hopefully it's been clear. I'm going to proceed to the next one. So I did few of these. The next one that I'm going to implement is filter. It's really close to the map operator, so it's a good example. Filter, the way it works is it's apply this function, but it only lets the values through when the expression is evaluating to truthy. So in this case, we are going to use the even numbers. We are going to let the even numbers go through, and the odd numbers will be just blocked. I'm going to use the same transform, so I'm just need to change this to follow the specification that I just said. So I'm going to use a little hack that JavaScript allows me. That is short-circuiting, the AND logic. So basically, this works similar to what we are all used to. Like for example, if we have this, we know that this is kind of a default value, and we are using the same logic, but instead of the OR, we are using the AND operand. So for the AND operand, the way it works is if this is false, it will evaluate to an empty instruction, so it will do nothing. And if it evaluates to truth or truthy, it will execute the next. It will just go and evaluate the following expression. In this case, it's executing a function. It's a little bit of a black magic, but it's just to avoid, writing the if. It's a little bit more funky. So that should work as expected, and we are getting the filter working. So that's perfect. The next topic I want to cover is schedulers. So schedulers is a nice API that allow us to change the context of execution for our observables, and this is quite advanced. So I'm going to start with how promises work, and I'm going to use the promise in ECMAScript 6, and this is just a simple promise. I'm not going to use implement reject. So basically, I'm going to resolve a value, and then when I execute this, I'm going to use a similar approach. I'm just going to console log this value. I'm going to just to see the difference of synchronous and asynchronous execution. I'm going to just output another value, and I'm going to do a small quiz, and I'm going to ask you which of the two is going to happen. So are you expecting the output to be 1 and then 2, or are you expecting B to be 2 and then 1? So how many people goes for A in the room? Okay. Not sure? Yes. And for B? Okay, a lot of people. Very good. So basically the difference is running the code synchronously or asynchronously. Well, sorry for the guys that choose option A, because this is going to be asynchronous and is the default behavior for promises. What will happen is when we run observables, another story will happen. So let me just get back the code just a little bit easier for me. So we're going to use this code. So I'm going to use a similar approach. Instead, I'm going to just use one value, just to make it exactly the same. I'm going to change that, and I'm going to output as we did before. So similar example, now using observables. This is going to push the value 1. It's going to call complete. So we are going to see the pipe on the console. And then there's also another console log at the end, after we have subscribed. So yeah, the same question. We have these two options. Who's going for A now? Okay. And then who is going for B? Okay, the promise guys are a little bit scared now. Yeah, the thing is, yeah, exactly, it's A, which is a little bit surprising. And everyone is introducing RxJS as a way of doing asynchronous processing, but actually, it's synchronous by default, which is a little bit, mind-blowing. What we can do is, obviously, this is this is a little bit, you need to know a little bit of JavaScript, and what we can do is, if we want to get a really easy implementation of asynchronous behavior, we just can call this our logic within a set timeout. But then we are forcing the observable to be always asynchronous. So we are losing, we are kind of losing some of the potential of RxJS. What we really want to do is use schedulers. And schedulers let us work with both synchronous or asynchronous. And this is one of the features of RxJS. And we are going to use subscribe on. And it's taking an scheduler as a parameter. And we are going to use the sync scheduler. And this will change the context, the execution context. So we are getting the asynchronous behavior that we are used to, or that we are used to with promises. There are other options. This is the default. It's using queue. And this will get the default behavior. But basically, that's what I wanted to talk today. A little bit in-depth exposition of observables. I hope you have enjoyed the talk. So if you have any questions, feel free to ask. Thank you.